Check 1, 2. Alright, so today we're going to be going over a board that has no backlight. It's a Macbook Air board, and it's one that I got from this company that sells all of these refurbished machines for people to fix and resell. And one of the things that I made the big mistake of is I actually knew what they were doing beforehand. I saw that this is a company that sells motherboards, and they advertise them as refurbished regularly, and I've actually bought from them before. So I kind of probed a little bit, and I was just kind of curious. So if you sell refurbished boards, and you're selling me this lot of machines that may have bad boards, so are these the boards that are like that you guys fucked with, tried to fix and failed at, or is this just stuff that you never touched? And no, we've never touched this stuff before. We would never try to fix these boards before sending them to you and just leave you the pile of crap. Yeah, I needed stuff for the course on short notice, so this had to do. So this has no backlight, and we're going to go over a couple other things that I'm going to measure first. So I'm going to turn it on. Try to follow along with you with a schematic on the screen here. So let me just open up backlight circuit. So this here is the backlight circuit. Alright, so the first thing I want to do is there voltage on the fuse? So we're going to go over and check the fuse while the machine is turning on right now. Going to turn it on. See what I get. And might as well move this over so you can see the voltage as I'm measuring it. Okay. So on the fuse, I get proper voltage. On the other side of the fuse, I get proper voltage. On output, I get 0. If I have output 0, it could mean a couple of different things. It could mean that I have a short to ground for some reason. It could be that power is not flowing through this transistor after the fuse. It could be that there's a blown via, a corroded trace. So let's just continue on and see what we get. So at this chip over here, at this Q7706, which is a transistor that's going to open based on the input signal of LCD backlight enable, let's see what we get. So in the beginning of it, I get 8, good. Now on LCD backlight enable divide, I get 8, bad. On output, I get 0. So let's put our thinking cap on here. Is the transistor bad because the transistor is not outputting power, or is the transistor not getting the proper input signal? So the source of this transistor is pin 4. The source of it is getting 8 volts. Then the gate of that transistor, pin 3, is also getting 8 volts. This is a P-type MOSFET, meaning that when the voltage in the gate is the same as the voltage in the source, that it will not allow power to flow to the drain. Therefore, this over here is working just fine. It is doing what it is supposed to do, which is close and not let power through the circuit. Now, let's look over here. So how does this work? So you have these two resistors over here that are a voltage divider between PP bus G3 hot, which is the input voltage of this transistor. You have this voltage divider going between the voltage in the source and then the voltage on the gate. The whole idea here is that this voltage divider is going to lower the power going to the gate so that it will open. Remember, this transistor will not open if the power that's on the gate is greater or equal to the power that's on the source. You have to lower it. And we have a voltage divider to do this. A voltage divider is going to go between the high side power source and where we want the power to go, and then where we want the power to go in ground. But unfortunately, there's this little crap in the way over here. This transistor sits in the way of the bottom of this voltage divider and ground. So what are we going to do to check if this is working the way it's supposed to? So these transistors are going to open and send this voltage divider a path to ground, but that's going to happen based on these two input signals. So when you have EDP, external display port backlight enable, and backlight platform reset, these transistors will open and send that power over to ground. So let's take a look and see what we get at those 2 points. Three, okay. And 3. Yep. Now, by the way, if you Google this, you'll see that this is 2 N-channel MOSFETs. So these are going to open and let power through when you have a higher or equal voltage on the gate as to the voltage of the source. So these are opening and allowing this to go to ground. So why is this not sending my power the way it's supposed to? So let's check the voltage divider. R7788 is supposed to be 301 kiloohms, and R7789 is supposed to be 147 kiloohms. So we change the multimeter over to resistance mode. Now, whenever you're measuring resistance or doing diode mode, you have to take off all the power from the machine. Let's see where those two resistors are. So Okay, those are over here. So R7789. Let's see what that looks like. R7789 is supposed to be. Let's see. I get 145 kiloohms. Schematic says it's supposed to be 147 kiloohms. Close enough. Now let's see R7788. Schematic says 301 kiloohms. And my multimeter says... My multimeter says 97 ohms. So instead of that resistor being 301,000 ohms, it's 97 ohms. Do you think my voltage divider is going to work properly? Probably not. So let's replace that affected area and see if it fixes our problem. So we're going to go over to the microscope camera, make sure the microscope camera actually works. Okay, let's move in over here. Turn on the Hacko. And again, you think I'm going to buy those resistors from Mouser and wait a week or two for them to come for me to put this machine in the window? Hell no. I am going to take them off of a donor board because we don't have time for that nonsense. So the best source of any of these parts is to buy a bunch of dead boards with the holes in them off of Alibaba, and then use those to take parts as needed. I'm going to replace both ends of the voltage divider just for the hell of it. Damn, that is bright as hell. Much better. The 3437 is a board that has a lot of heat sinking. Not a lot, no, that's the wrong word. It's multi-layer PC board, and in whatever way they designed it, whatever materials they use, this thing just it absorbs heat like crazy. So if you have some kind of IUE station, it will just laugh at you. Good luck getting anything off of this board with a cheap ass hot air rework station. It'll make you want to cry. Okay. Now that I have those two resistors off, I'm going to put some solder on the pads. Not exactly rocket science tinning those pads. I'm going to pray that I don't make that resistor flick away. I'm going to let the hot air move it into place. There we go. And the other resistor in that voltage divider is down here. That is terribly out of place. And we just flick it into place, courtesy of hot air. Okay, now that that is all flicked into place, now what I want to see is when I'm done, does this actually work? So we're going to try turning it on and see if I have a backlight. And if we don't have a backlight, I'm still going to want to measure around and see if anything changed. So if you have any new stuff. Alright, it's going to turn on, turn off, turn on, turn off, turn on, turn off, then turn on like all of the 2013 Airs do. Come on. Alright, so that didn't work, and also unfortunately when I actually did manage to follow up and fix it, I forgot to fucking hit record. So I managed to hit record all the way at the end for me talking, but I didn't show you what I did. So I'm going to go back and show you what I did here to fix that problem. I want to show you what was actually wrong with the board, because it's something that doesn't happen often, but it's something that you should know how to fix. It's something that you should see. So let me load up the schematic here, and after I load up the schematic, I'm going to show you what it is that I did. Alright, so this here is the voltage divider that wasn't working the way it was supposed to. Now, after I replaced the resistor, over here, it still measured 89 ohms instead of 301 kiloohms. So this to here has a path through here. So my original assumption, which was wrong for several reasons, was that this resistor must be bad. Now, the first reason that this assumption was wrong is that resistors, when they blow, 99.999% of the time, when the resistor blows, it blows to a higher resistance, not a lower resistance. So the first thing I should have thought is, what other path could it be taking the signal to go from this pin over here to over here? Pins 4 and 3 of this transistor could be shorted, or this capacitor could have blown and have been the problem. And the problem here was this capacitor. So this capacitor here was broken. Now you may ask, well, why don't you measure the resistor out of circuit? Measuring the resistor out of circuit is the proper thing to do. Like, have you tried to get one of these resistors on your desk so that you can measure it out of circuit? I mean, really, have you ever actually tried to take a size 201 resistor off of the motherboard, place that fucking resistor on the desk so that you can measure it out of circuit, and do this? Because you know what's going to happen to that resistor? The second that you touch it, it's going to take that little touch, and it's going to fly right away to the 6th dimension, and you're never going to see it again. I don't measure things out of circuit because 99%, I can't. I really can. And then you say, well, what if you use smart tweezers? I'm going to take it off of the board. I'm going to put it on the desk. I'm going to grab it with the smart tweezers. Whoop! It's going to. I just know it's going to flick away. And also, my smart tweezers got water damaged by my air conditioner leaking on them the day that I got them, which is something I should really send back. But yeah, that's that. And you're going to see later that the board does actually work. That was the problem. I was being an idiot and doing the wrong thing to fix it. And alright, so this thing died while I was recording because my stomach hit something over here, I think. I don't know what I did. I hit off. Maybe I bumped into it. Anyway, let me just show you that I am working on the same board. Not BSing you. This is the same board where I replaced that capacitor on. See, I replaced the voltage divider. You can see because it still has the flux around it. And that is... Let's turn the thing on so that you can see that it has a backlight and see that it does indeed work. Plug it in. It's going to do the turn on, turn off, turn on, turn off, turn on, turn off thing. And then once it turns on, I have to wait for it to get to the question mark. So anyway, the whole point here is you have to figure out what was wrong with your board. You can't, follow something on the internet that says, this thread says check this component and replace this thing. Every single time it's going to be something different. I've been doing this for a long time, and this is the first time that was the actual component that needed to be replaced. That's never happened before. It's never been that little piece. But this time it was. So really, you just have to understand how the components work, go through step by step in an analytical and logical fashion, analyze, compare, contrast, measure, and learn. And if you do that, you'll be able to solve these problems. If you don't, you're not, and you're just going to be wasting your time. So, come on. Here we go. Backlight. Beautiful. Another board that Macentech couldn't figure out. Yeah, I have an entire box here of boards from them where like half of them have it's like, we never touched them. We never tried to fix them, and like the BIOS chips are on backwards. Like, just get the fuck out of here. But yeah, another one that I can put in the window.